All right, guys, so here's one more section in here on the rational expressions and equations. This one is going to be solving equations, and the last section was about just simplifying expressions. And there's a lot of similarities here, but there's kind of one main difference in the mindset. And the idea is with expressions, like on the left there, if you're just adding two fractions, or we even did multiplying or dividing, um, you really just want to try and reduce as much as you can and combine. And for addition and subtraction, really, it's not so much reducing, it's just getting that common denominator. So in this case, it would be 12, just by looking at the 3 and the 4, right? So we know that we need to get them both with 12s in the denominator, and it's just kind of a matter of multiplying top and bottom, and this one by 4, and this one by 3, right? So we can get that common denominator so that now we can add the numerators and just keep the denominator as 12 there. Okay, but when you're solving an equation, it's a little bit different. We actually want to, instead of just getting a common denominator, since you're trying to solve an equation, the goal more is to get rid of all of the fractions, okay, and get rid of the denominators and get yourself an easier equation. And I set this up purposely where the denominators are 3 and 4 again, so 12 is what we used in the expression, right, as a common denominator. So in this case, 12 is what we're going to use again, but just in a slightly different way. Okay, so instead of rewriting these both over 12, and you could do it that way and then combine the terms and everything, but you're still going to have that 12 in the denominator. So with solving equations, the approach we usually take is instead of just getting the common denominator, we're actually going to multiply the entire thing by 12. And since it's an equation, we are allowed to do that, right? Because you can multiply both sides of an equation by something. And just kind of showing all the steps here, what ends up happening, it would be 12x over 3. So I'm just multiplying the numerator by 12, and the denominator is staying the same. Don't forget that 5, though, would also need to get multiplied by 12 to become 60. And then the idea is that if we multiplied by the correct thing, in this case 12, each of these should reduce down and we should not have fractions anymore, because 12 over 3 is just 4, and then the 12 over 4 is just 3. Okay, so we would get an equation that is actually solvable, and we could divide both sides by 7 and get x equals whatever 60 over 7 is. Okay, so that's kind of the idea. We're still going to be using that least common multiple, but instead of just making it a common denominator, in this case we are going to multiply the entire equation by it. So let's run through a couple examples and see how it works. Okay, so here's example 1. So we have 3 over 4v plus, equals 1 over 4 plus 4 over 4v. So again, my thought is I'm looking at these denominators first, and kind of ask yourself, what would be the common denominator if you were doing it that way? And in this case, hopefully you can see that it would need to be 4v, okay, because this middle term here, we would just have to multiply top and bottom by v, and then they would all have 4v. So the least common multiple is, again, 4v of the denominators. So what we want to do, again, since it's an equation, we actually just want to multiply the entire equation by what the common denominator would have been. Okay, and it might be helpful, throw that 1 underneath there. Okay, and I'd encourage you guys just to do the numerators first and then reduce later. Eventually you might be able to do this like 2 steps at the same time, but what's going to end up happening is when we do the 4v times that first term, the 4v times 3 is 12v, but the denominator is 4v. Okay, and then the middle term, 4v times the 1, and the denominator is still just going to stay 4. And then the term on the far right, 4v again times 1 over 4v. And then what ends up happening, just like in the previous problem, we do get some terms canceling out, right? That's the key here. 12v over 4v, so the v's cancel, and 12 divided by 4 just becomes 3. The 4v divided by 4, the 4's cancel, and we just get v. And then 4v divided by itself, it actually equals 1. It doesn't cancel to 0. Remember, something divided by itself is 1. And now check out this new equation. 3 equals v plus 1. Right? Pretty straightforward now. Just subtract 1 from both sides, and we will get that 2 equals v. Okay, and that's going to be our answer. Now, there's one last thing you need to check, and that was the idea of restricted values. If you remember from previous, like when we were graphing and everything, and simplifying, any value that makes the denominator 0 is going to be a restricted value. So in this case, if we look at those original denominators again, the only way we would get a 0 in the denominator is if v itself were 0. So v equaling 2 is good to go, but if that happens, you get what's called an extraneous solution. We saw those before, so you just need to kind of double check. Okay, another example here. 4 plus 1 over n minus 4 equals 2 over n minus 4. Okay, and again, same kind of thought process. I'm looking at, really all I'm worried about, I want to get these fractions out of the problem. I want to make myself have an easier equation to solve, actually. So the least common multiple of n minus 4 and n minus 4 is just n minus 4. So that's the thing, that if we were going to make it a common denominator, that's what we would be using. But since this is an equation again, instead of getting a common denominator, let's multiply the entire problem by n minus 4. Okay, and I'll put 1s underneath the terms that don't look like fractions just to make things look nicer. So this first term here, I'm going to write it as 4 times n minus 4. Okay, the denominator is just 1, so I'm not even going to write anything. When I distribute the n minus 4 to the second term, it's just getting multiplied by 1 up top. But its denominator is n minus 4 also. Okay, and that whole term is actually going to cancel out to be 1 in a second here. And then in the next step, it's 2 times n minus 4 over n minus 4. Okay, and hopefully we can see in that term on the right there, the n minus 4s are going to cancel out. It's just going to become 2. But again, I'm just showing every single step just to, not miss anything. Okay, but let's say we have that part. Now let's go ahead and do some simplification. 4 times n minus 4, that 4 can go ahead and get distributed to become 4n minus 16. Okay, this middle term again, something over itself is just going to turn into a 1. And then on the other side of the equal sign, the n minus 4s do cancel, so we just get a 2. Okay, so we have ourselves, at this point now, no more fractions, right? That was our entire goal. That's why we multiplied by n minus 4 there, so that we could get to this step and not have any fractions. We just have a more straightforward equation. Okay, so to solve it, just finish it like a normal equation. The negative 16 plus 1 is going to be a negative 15. We will add 15 to both sides, so 4n will equal 17. And then just divide by 4, we get n equals 17 over 4. A lot of times you do get fractional answers here, so don't worry about that. But then just take a peek again at the original, our original denominators were n minus 4 back up top up here. So really the only restricted value or the only thing that could give us a problem is if n equaled 4. So our 17 over 4 seems good to go. It is not extraneous. All right, so let's solve one more equation. This one is a little bit larger. We're going to have to do some factoring in the denominators if you notice. So pretty much anytime, if you see something that's factorable, let's try to factor it. So the n squared plus 2n minus 3, we could write as n plus 3 times n minus 1. Okay, that n plus 3 is fine, but this denominator over here is actually the same thing again as the first one. Okay, so we just kind of factored those out. And now again, kind of think about what would you be using as a common denominator? What is the least common multiple of those denominators? Okay, and I can see from the first denominator on the left, we would need an n plus 3 and an n minus 1. Okay, now looking at this middle term, it had the n plus 3, so it would just need an n minus 1, okay, but the n plus 3 is part of it, so we're good using the n plus 3 and the n minus 1. Again, if we're just going to add these, this is the only term we would need to multiply top and bottom by n minus 1, but we're not doing it that method again. Okay, and another thing what you can do to check before you even get started is if we multiply all the terms by that least common multiple, is it going to cancel every denominator? So if we multiply by n plus 3 and n minus 1, is it going to cancel that and that? Yep. Is it going to cancel n plus 3? Yep, that's part of it. And then that and that again is the exact thing we're multiplying by. Okay, so let me just clean this up a little bit, and then we will do the multiplying. So we have n plus 3. I'm just rewriting the term here a little neater. And what we are going to do is multiply the entire equation by n plus 3 and n minus 1. Okay, so let's do that. Multiply the entire equation by n plus 3 and n minus 1. And I want to leave them separate like that. I don't want to FOIL that out. And actually at this step, I'm not going to distribute anything out in the numerator yet, okay? And you'll see why. But when I multiply that times that, we're going to get n plus 3. I'm not multiplying anything out, actually. I'm just writing them next to each other. Because the denominator, n plus 3 and n minus 1, we can see, hopefully, that some of these factors are going to cancel in a minute. Okay, then I'm going to distribute the n plus 3 and n minus 1 times that 4. Okay, and it's still over n plus 3. And then I'm going to distribute the n plus 3 and the n minus 1 to that guy. Okay, I'm going to write a little smaller so this all fits here. N plus 3, n minus 1. And its denominator was n plus 3 and n minus 1. Okay, and again, the reason I'm showing it like that is so that it's very clear to us what's going to cancel. Okay, now some of you guys can, again, maybe get to this next step by just looking, you know, this and this is going to cancel that and so on. But I'm just going to do that at this step. So the n plus 3's cancel, the n minus 1's cancel. We're left with just n. Okay, in the next term, only the n plus 3's canceled. So I'm left with 4 times n minus 1. I'm going to go ahead and distribute that out. And then on this far right term, the n plus 3's and n minus 1's cancel. So I'm left with just the 2n plus 12. Okay, and this is the step now where we are at a much nicer looking equation right there. No fractions. This should be like a normal equation. Sometimes it might be a quadratic or something, but it's going to be a nice straightforward equation. So let's see what we can do. Start combining some terms here. 4n plus 2n over here is 6n. The minus 4 and the plus 12 is going to be plus 8. Then we could go ahead and subtract 6n from both sides and get negative 5n's equal 8. And just divide by negative 5. Okay, n's going to equal negative 8/5. Okay, now go back again and make sure that none of your answers were extraneous solutions. And in this case, it looks like the only exclusions would have been negative 3 and positive 1. Those were the restricted values. So our answer down here of negative 8/5 should be totally good to go. And that is that. Okay, so just remember with these again, instead of just getting a common denominator, we are actually multiplying the entire equation by the common denominator, and then that clears the fractions. That gets you to an equation like this with no more fractions in it, and those are much easier to solve.